This is part 10 of the Loopstation sampler tutorial, and we're using SuperCollider and processing and even Arduino to make a sampling loop station. So we got into, we pretty much went all the way finding one track worth, and now we're trying to do more than one track worth of samples, so we can have more than one track, one sample going at a time. And we got as far as creating these beat markers, so we have multiple beat markers. And it really was just this process of using these for loops. So now what we're going to do is we're going to create a way to record unique separately on each track. All right. So let's go down actually in our processing code. And this is the code left over from last time. So if you've gone this far to part 9, you should have all this code. And remember when we pressed the mouse here way back in the day, a few tutorials ago, to turn recording on and off for one track, we have this record toggle, which oscillates between 0 and 1. And if it's 1, then we send an on message to right. I mean, it doesn't exist. Well, anyways, we send this on message to SuperCollider, and then we send an off message to SuperCollider. The thing. Now we have to make multiple tracks. Now, did we fix it in SuperCollider already? Let's pop back to SuperCollider and rec on. And yeah, so we have these play synths track number and record synths track number set. So yeah, we did sort that all in SuperCollider. So in order to turn recording on for SuperCollider, we have to give it the name of the track, the number of the track. Okay, so we have a little bit additional information to send. All right, and not only that, we're going to have these record toggles. So we have to do a few things. It's a bit involved. So like I said, making multi-tracks will get us to pretty much alter our code. We have to rewrite some of it. And not completely. The concept is still there, but we just have to alter it. So since we just had the one track, we can do an if mouse x is less than width. But now we have to make sure the y area is where the mouse is within the track. Okay, so we're going to have to sort that, the if statement. So we're going to have to determine which track the mouse is hovering over, and then whether it's on the left or the right. And then we need an array of these rectogs now. So we're not just having a record toggle for one track, but for all the tracks we have, right? Okay. And then we're going to send record on, but we have to add to the OSC message of the track number. So the rec on OSC def is receiving the track number, and then it's setting the track number here. So it's going to the play synths and the record synth of the track number. Okay, so that's a little bit of work to do. So first things first, let's make sure that we have more than one record toggle. And it's the same technique we've been using up to this point. We're going to create an array of them based on the number of tracks. So that a number is growing more and more important, this number of tracks. And it'll be just a one-shot thing, so that when we change that number, it'll be passed down. So this is using variables really effectively. We'll change that, and then it'll change the number of everything that we make. All right. So just like we've done before, we created a well, maybe we didn't do so many before. I thought we did. So now we need an array. So I guess this float, is that samp array? Oh, that's a thing. So maybe this is the first time we're doing this. Interesting. Okay. We're going to need to create an array of those recording toggles. So instead of record tog and play tog, and we might as well do them both since we're here, we're going to have an array of integers. Okay, so we're just going to change that to something like that. All right, and what we'll do is we will then initialize them in setup. Okay, so what we can do is we can just put them all on the same line to be a little bit efficient. So we can have an array of integers, one called rectog and one called play. TOG, we'll call them play togs. Okay, and just to review a little bit, we did follow a similar procedure here in SuperCollider, where we created, we used to have just one play synth and one rec synth and one buffer for the tracks, and then we just created an array of them so we can have the number of tracks worth. Okay, So that's what we're doing here. But this is the way you create an array here in processing. Array of record togs, an array of play togs. All right. Now in the setup then, we're going to initialize those. And so let's just do that down here after all this calculations here. And we're going to follow a procedure similar to what we did here with a sample array. Okay. So we're going to go rectogs, which is supposed to be an array of integers, equals a new array of integers, new int, with an array size of num tracks. Okay. And then it will make sense. So on our original code there, I guess the record tog was 0, right? Because when we click the track on the left side of the track, we want to be able to start recording, right? Okay. So we're going to fill all the, right now, when we create a new int and let's say that was 8, an array of 8 integers, but they're all nil, right? So we want to fill those with 0. So we just do a for loop, and we can do that on one line like we did here. So we're going to say for int I equals 0. I is less than num tracks I plus plus. For that, we're going to make rectogs I equal to 0, right? So, rectog 0 will be equal to 0, 1 will be 0, 2, all the way to 7, or whatever our number of tracks is. Okay. And then we can just do the same exact thing for play togs. So we'll just update like that. Copy and paste. Play togs, number tracks, play togs. Okay. Except we want play togs to be 1 because we want them to be playing from the get-go, from the start, right? So we're going to set all those to 1 because we want them to be playing. We want to record something, and then when we stop recording, it'll play it back, right? So we want the next time we click on it to pause it, really, to stop playing it, okay? So now we have an array. That's good. We have an array of rectogs, an array of play togs. So let's first start with our mouse-clicked business, and let's make sure we update. We're going to have to put all this code here into some kind of for loop, okay? Right? So, and then we can do the if statement. So why don't we actually deal with the if statement first, okay, since it's just going in order. Okay, so let's see. This is for one track. Remember, turn rec on and off for one track, this code. And let's just review. So we said that if we're clicking on the left side of the track, so mouse x is less than the width divided by 2, we're going to update the rectog. So rectog is going to equal to itself plus 1. So if it started at 0, then it'll become 1, and then just modulo 2. So just keep advancing, but it'll always be 0 or 1. So if we get to 3 modulo 2 will be 1, right? And then 4 will be 0, 5 will be 1, 6 will be 0, etc. Okay? And then we're just going to say, if it is 1, send a super collider an OSC message, record on, and then of course we have to update this with some information, the track number, okay? And otherwise, if it's 0, then it'll be off. Okay, so all of this now has to be couched within a for loop, okay? Because we're going to do it for multiple tracks. So we'll say for int I equals 0. I is less than num. We can do number tracks, or we can do rectog's length. We'll just see num track. I plus plus. And then put the whole thing in there, right? So open curly, and then this is the end of that if statement there. So we'll put another close curly behind there. And then we can just use Control T to re-indent everything. Okay, so now this is all in a for loop. And then now we have that variable I to work with as well, which is readable in here. So the first thing we have to do is we have to determine which track we're hovering over. Okay, so let's do that. So we're going to put an if statement again. We're going to sandwich it in here. Okay, so this ends there, and that one ends there. So we're going to sandwich, if we sandwich an if statement there, we're going to need a close bracket between those two. So I'm going to put the close bracket in first so I don't get confused. And then I'm going to sandwich an if statement in there. Okay, and then I'll just do this and then this for now, and then I can line everything back up. Okay, so we're going to have to determine which track the mouse is standing over. Okay, and how do we do that? So it's a y value. So we're going to say if mouse y, right? And then, so if we're looking for the first track, it'll have to be greater than 0, right? And I don't know if you remember these Boolean operators, but you do and that means it has to fulfill both conditions to be true. Okay, and then this like that is or, so either condition to be true. But in this case, we need an and, so it needs to be both. The mouse y needs to be both greater than 0 and less than, we have that one variable called track height, right? So that's for the very first track. Does that make sense? So if our first track of our mouse is greater than the 0 but less than the track height, then we're definitely somewhere on the first track somewhere. Okay. However, that only is good for the first track. What if we're on the second track? Then this is no good. So we're going to use I in a way. Okay. And so this 0 instead will be I times track height. Okay. And then it'll be I times, so we're going to put that in parentheses too, because the greater than, it might just think of itself as greater than I, and then times track height might not factor in. And we're going to do I times track height, but add, oops, sorry, I didn't mean to put a plus, I meant to put a parentheses there, and add another track height. Okay, hopefully you followed along, but let's test it then. So if I is 0, it's the very first track. If mouse y is greater than 0 times track height, or 0, and 0 times track height, which is 0, plus track height, so it's between 0 and track height. So that's track 1 or track 0 in this case. If we're on track 2, for example, it's going to be 2 times track height between 2 times track height, right? So if you think of track height 1, track height 2, so 2 is track number 3, right? Or the third track, 0, 1, and 2, right? So if you think 1, 2, right? That's right. That's the beginning of the third track. And then 2 times track height, which is where we are, plus track height, so 1 more track height. So it's between the second and third barrier. So that works. So if mouse y is anywhere on one of the tracks, that's what the I will be. So if this is true, that means my mouse must be somewhere touching track 2. So if track 2, then this condition must be true, right? If my mouse is over track 3, then I will be equal to 2. Well, let's just start at 0. So we'll call it track 0 is for the first track, track 1 for the second track. So if I'm over track 3, which is the fourth track, track number 3, then this will be true, right? Okay, so that just makes sure which track I'm over. And then we just do the mouse, we can just do a blunt mouse X is less than width, because if we press the left side of our track, that's when we record. If we press the right side of our track, that's when we pause, play and pause, okay? So that's good. So that takes care of the if statement, and that just takes care of it so that determines which track we're moused over. And you notice that number of tracks here will adjust. If we change the number of tracks, it'll still be, this if statement will still hold. I guess track height is also calculated, so that's a key thing. So track height is 120. I guess, right, I guess that just works itself out. You probably should have calculated that slightly different, but it's fine. It'll be fine. Okay, where were we? All right, all the way down here on the mouse pressed. Now, we need to update the rectog because we're not just dealing with one rectog, we're dealing with an array of them. Okay, but we don't have to do a whole for loop and look through it all because we already have I, which is going to be correct. So if we're over there, then I has to be the track that we're over. Okay, if this is true, then we're definitely over track 2 or track 3 or track 4. Okay, so then we'll say rectog I equals rectog I plus 1 modulo 2, right? So then we just update that particular rectog. Okay, and same with here. So we'll just copy this square bracket I. If rectog I is equal to 1 instead, oh, so this updates it first. So rectog I equals rectog plus 1 modulo 2. So it increments it either to between 0 and 1. And then we just do the 2 if statements. And we just have to update that we're looking in the array. So it's rectogs also. Don't forget about that. It's not rectog, it's rectogs. So rectogs I is equal to 1. Okay? And let me just skip over this for now and update this as well. Rectogs I is equal to 0, then we're going to send this message. Okay? Now the one last bit we have to send to SuperCollider is it's expecting the OSC def is expecting a track number as the message 1, as a little bit of data. So then it can set the synth, the right synth. So it's either going to pause track 1 or track 2 or track 3. It'll record on track 1, track 2, or track 3. All right. So we have to send that track number data. So I think that's the last little bit we have to send. We'll find out. So that's easy enough. We take our message, which we called RON, R on, record on. So RON dot add. And we're going to add the track number, which in this case will be I, right? Because that's how we solved for it there. Just make sure that's the one our mouse is hovering over. So it'll be I. Okay. So that's easy enough. So we'll copy that bit too. And we'll paste it in this message as well. So record off will be the same thing. We're going to add the I. Okay. So there you go. So it makes our code a little bit more confusing, I guess, because we add one extra layer of abstraction so we can do multiple tracks. But if you follow it step by step, if you take a little bit of time and follow each thing, it makes a lot of sense. So we're going to go for loop through all the number of tracks, 0 through 7. And then this line will tell us which track we're hovering over. So if we're hovering over the track, then I becomes that track identity or track thing. Then we're going to look at if our mouse is on the left side or the right side. Decided that we're going to click left for record and right for play and pause. This is going to change later on, and you'll see when we want to do some looping and such, because it'll make it difficult to grab loop areas. But we'll deal with that, cross that bridge when we come to it. Then this here increments our record toggle, because remember we want it to go between 0 and 1. So each time we press it, we're either recording or we're stopping recording, right? We press it again. So it's toggling instead of having 2 different buttons, one for record on and one for stopping recording, right? And then these are our conditions. If it's 1, then we're going to record, rec on. If it's 0, then we're going to stop recording, rec off. Okay? So we're going to have to do something very similar for the play area. So let's scroll down here, the play pause. Okay? And let's just, again, we're going to put our if statement in there. So remember, this is, we can even mark this. This is the end of the draw, end of mouse pressed. Okay, so that we need that bracket to end our mouse press. So if you put it at the end, you'll see it lights up there, mouse pressed. Okay, so we're going to keep that curly bracket, but then we need our if statement is ending here, and we're going to put one on top of that, right? That's our for loop. So we're going to add a curly bracket here after the if end curly bracket, and we'll put our for loop before the if. So for int I equals 0. I is less than num tracks I plus plus. And then start that curly bracket for the scope of our for. And you notice then it highlights the one we added down there. And remember, we sandwiched in to tell which track we're over, so we'll do the same thing. We can even copy it from above, but we'll just type it again. If mouse y is greater than, and I'm sure now, I'm wondering if I put the right, sometimes I get the things confused. Greater than, good. Sometimes I get the direction confused. Oh, and then I forgot to put the condition, so that'll throw an error. So and I times and mouse y is less than. So we have to add that again. We can't use it from before. So that was a mistake. Y is less than I times track height plus track height. Okay. And this is the 2 bits of our if, right? So it has to satisfy both these conditions. And we're going to have to put that whole thing into a parenthesis so that it captures all of that. So I did forget about that, right? Okay, so mouse y needs to be compared to this whole thing, I times track height plus track height, okay? So we're going to enclose the whole thing in parentheses. Enclose that in parentheses so we know to do the multiplication first. So, you could copy and paste that line, but we can retype it as well. So if mouse y is greater than, again, I times track height, okay, in the parentheses so that it's the whole thing, and meaning we must satisfy both conditions, mouse y is less than, parentheses I, and then another parentheses, I times track height plus track height. And then end that whole thing, and then end the if. Okay, and then open the if statement, right? Okay, so that's going to determine which track we're on, and we're going to sandwich that if statement between these two, right? We should have done that first. Now it's getting confusing, but you can always check like that. So that should end my for loop. It does, and then this should end the if statement we just added, and it does there. Okay, and then of course that one. So then we can just check if it's on the other side of the right side of the track. And then we just have to update these to reflect our array. So it's play togs I, right? So let me just copy that S and the I. So it's play togs I, and then same here. So if play togs I, we're going to increment it. If it's equal to 1, it's playing. If it's equal to 0, it's paused. Okay. And then we have to add our bit of message because the new OSC def in SuperCollider is listening for both this OSC message play, but also for the track number. So we're going to do PMSG. Now, I did forget, now I'm realizing I forgot to write the same message because this is our RON. So RON add is the message name of the OSC message, add I. But this is a different message. We're sending R off. So this guy should be R off. So that would have been a little mistake. And basically, it just would have kicked an error saying we don't know where R on is in that context. So we got to make sure we use the PS message and the P message. Okay, so P message.add I, okay, for the track number. And then here too, we're going to do PSMSG, so pause message add and I. Okay, so then that's going to update our play tog. So now, depending on which track we're hovering over and which side of the track we're pushing, it's going to either play or record and send the proper message to our OSC defs waiting in SuperCollider. So now we can record and play different ones. Okay, and then we'll have to deal with this later. But this is the last thing, is the waveform display, and it's one extra layer because we already have a for loop going on for the buff size. So we will attack that in a little bit, or maybe even the next video. Okay, so I think this should be good. I think we should have everything ready here so that we can, we can record and play and pause for each track. Okay, so let's run it and see if we made any mistakes. I think I caught several of them, but hopefully, oh yeah, okay. So float can't be to int, so rectogs, and why are they floats? Rectogs, play togs, new int, number of tracks. Rectogs, no, int, rectogs. Sorry, I'm not sure why that's a problem. Ah, right, number of tracks is a float. Oh, because I went through and I updated that because we're having some lineup problems. I think it would be innocent enough to make that an INT and not throw our calculations off. Somehow there were some rounding errors. So let's do that. Because for the amount of items in an array, it has to be an integer. Another thing we could have done is, if that does still introduce a rounding error, we could just go int number tracks, but then we have to update all of them. So let's try this. Let's see how that goes. And I did not, this update waveform, right. Okay. So, and that's something we're going to tackle later. So we can either just, maybe best to just comment all that out until we can address that. So I'm going to open comment out and go to the comment out both and the draw waveform. Comment that out as well. Okay. And let's see if that'll run. And it looks like, the record highlighting and pause highlighting. So let's get rid of those as well. Oh no, this one we can actually update. We just forgot to do it. So let's take a minute now to deal with that. So we want it to, if we're pressed that track to record, we want it to highlight that particular track, right? All right. So we're going to go a for loop, okay, in here, and we'll just put it above all that. I already have like some crazy for loops going on in here. Beat markers, right? Right. Okay. So because it's a double, yeah. So anyways, we'll do a for loop here, and again, we're just going to update that particular track. So we have to do some checking, okay? And we have to draw the rectangle over the right track, right? So for int I equals 0, I is less than num tracks I++. And it's going to cover both this play and pause highlighting. Okay. Then we're going to say if rectogs I is equal to 1, right? And play togs I is equal to 0. Okay. And then we're going to make sure it's the right rectangle. So it has to be that actual track. So again, it's very similar to how we were checking if the mouse was hovering over one of the tracks. And the way we do that is we put the X will still be 0, so we can maintain that because it's the left side of that track. And the Y, though, will be I times track height, right? So let's test it. 0 will be for the first track or 0th track. It'll be 0, Y will be 0, right? Let's try the third or second 2th track. 2th times track height will be 2 times track height. So 1, 2, and that's the beginning of the third track or the 2th track. Okay, so that should work good. And the same will go here too. So we can just copy that I times track height and pop that into there. Okay, so let's save that and see if that runs. Okay, good. It runs. Fantastic. Okay, now then I'm going to run all my Super Collider code and get it going and see if we can play and record. So I don't know where I left this, so I'll recompile. I'll boot my server. I'll send all my Super Collider code there. Oh, I didn't check it, so I made some mistakes from the last time. So you should update your code too when we figure this out. Waveform.value, right, because we've updated all these things. Dot value track n. Right, so this is actually track instead of track n. That's all that mistake was. Okay, so that works. And then we're going to start our initial synths. Okay. And let's see, and yeah, our index is starting. And let's see if we record on track 1. Hello, hello, hello. Oh, somehow, right, the width and height didn't quite work out. But that's fine, we'll stop that. And let it come around and see if it recorded. Track 1. Hello, hello, hello. Okay, yeah, I'm having these sound card problems, so just bear with me. I need to replace my sound card. And let's just do track 4. We can't tell right now because it's not drawing the waveform. Hello, hello, hello. Oh, somehow. Oh, right. The width and height. So we can pause that. That won't play that. And I already know the mistake I made with the highlighting. So track 4. We can't tell right now because it's not drawing the waveform. Hopefully this is not distorting onto the video, otherwise I'm in trouble. Oh well, we'll figure it out. Okay, so let's just fix that bit. We'll just fix that bit with the highlighting. Okay. Right, so let's fix the highlighting business. So we're drawing from this point and drawing a rectangle that's the width and the height, right? So we just have to update. So width is fine because we want to highlight the whole track. But the height, of course, is just going to be track height. Yep. And, of course, for the pause as well. So we'll save that. We'll run it again. And we'll just test it like that. Then that works. Great. Okay. So that's fantastic. Everything seems to be working okay. I just have to sort of fix my mic. Just bear with that. Forgive me for that distorted bit. I don't know, something about the sample rate or something's going wrong. I think my sound card that's on its last leg. It's one of these Apogee ones, and it's kind of held together with duct tape and stuff. So, though, it's clear coming into the video. Anyways, you don't need to worry about all this stuff. All right. Now we're going to finally update this waveform. All right. So it's a little bit trickier. It's, I don't want me to panic, folks. It's nothing to panic about. It's just we have to put kind of a for loop within a for loop kind of thing. Yeah. So we just have to make sure we get our P's and Q's and everything correct. It just takes a little bit of concentration to keep track of everything. All right. So let's go all the way back up here, and we do have an array already. We took care of the waveforms up here, didn't we? We have an array of waveforms. We have right. It's going to find the. Is it going to find? We have to go to our function here, our waveform function, and right. It has the track number already, track n. Yep. Okay. So it's going to pass that argument in the buffer as well. Okay, and then our OSC def does that already. It passes in the track n, and its track n will be the buffer, and then the track number as well. It's a bit redundant, but it's easier to handle this way. Okay, instead of sort of extracting it from the buffer. Now, right, so back to the processing side, and we have, remember, a sample array, which is this buffer size, right? So it's an array of values that's going to be, a resample. Just like every pixel will have some kind of Y value, which is the amplitude of that sample, right? So it draws a nice little jaggy waveform display for every pixel in our track. Now we simply have to create an array of these arrays. So we have to make one of these sample arrays for every track, right? Okay. So we're going to make a two-dimensional array, they call it. So basically, it's an array with an array. So let's just look at that really quick. I'll create a new thing here, okay? And so if I do something like this, int a, okay, equals, and then in processing to declare an array, like from the get-go, you use these curly brackets. Don't ask me why. So we'll go 765. Okay, so that's array of integers called a, and each a will be 765. Okay, and then if we want to create a two-dimensional array, we'll just go int and then put two sets of things like that. Okay, that means for every index spot, what will be inside it will be another array. Okay, so for example, it will equal a, and a. Okay, so 3 copies of that a. So this will be the array 765 in the slot 0, In slot 1 will be another 765, and slot 2 will be 765. I mean, if you wanted it to be a little bit more clear, we can make an int b and call that 432, or even just 4 and 3, like that. So we can have A, B, and A. Okay, so this will be 765 in slot 1 of this. Oh, we have to give it a name. Okay, of course we'll call it C. And so C0, C slot 0 will be the whole array of 765. C slash B will be 43, and C slot 1, and C slot 2 will be 765 again. Okay, so we want to print. Let's just do C 1, which is the second. What's the 1th or the second one? Okay, run that. And it prints the array. There you go. 4 and 3, right. 4 and 3. The array 0 and the 1, 4 and 3, right? Because we're printing the B. Okay, so hopefully that kind of makes sense. All right, so back to this now. For each track, we'll have a separate samp array, right? Okay, so let's go back up to where we declare our variables. And we're going to have a float samp array for every track. Okay, so we're going to call samp arrays. And we're going to make a 2-dimensional array. All right, so an array of arrays of floats. So every slot of the samp arrays array will be an array, right? So it's an array of arrays. I hope that makes sense. So in the slot number 0, in samp arrays square bracket 0, that will be equal to an array. Okay. Oh, and I forgot in my example. Well, I did show. Sorry. So actually, sorry. So I did this wrong. So if we wanted to grab, say, the number 3, we'll just double things. So C1 will be this B. Okay, going back to the example, put yourself back here. So C1 will be the array B, which is 4 and 3. And if we want to get that number 3, we're going to go C1, 1. Okay, so that will be the number 3. If we want to get the number 4, we'll get C1, 0. So C1, which is the second slot, will be B. And then within that array will be the 0, will be 4. Okay, run that, and you see that's 4. Okay, if we wanted to get the number 7, we can either do C0 or C2. So let's do Z0. Okay, and within C0, which is 7, 6, and 5, we want to do number 0. So it'll be C0, 0. And it'll be the number 7. If you want to get number 5, it'll be C0, 0, 1, and 2, C0, 2. And that's 5. Okay, so it's just like, I don't know, a bit like chess or something, just keeping track of where everything is. Chess is not the best example, but that sort of thing, like memory, like Rubik's Cube or something. Okay. The 2-dimensional array. So for every track here, so samp arrays 0 will be that sample array for track 0, or 0th of the first track, or the 0th track. Samp arrays 2 will be the third track, or the 2th third track. It'll be an array there, all the samples for the third track. Okay. So now we have float, 2-dimensional float array samp arrays. And here, how we said we initialize a buff size, right? We can still do the same thing, except we have to do a 2-dimensional thing. So we're going to say samp arrays, we've updated that, equals a new float. And the first thing array part of the size will be num tracks, right? Because we want 8 arrays. And within the array in each one will be the buff size. So it would be 1,000 or something like that, right? Because 1 for every pixel. So we're going to have an array of the length of 1,000 times 8, right? Okay. So we create an empty array that has 8 arrays in it, 0 through 7. And for each one of those, it has an array that's 1,000 long, 1 for every pixel. Okay. Now we just have to double for it. Okay, double for loop it. So we're going to have for int I equals 0, and then I equals sample arrays dot length. Okay, which if it's dot length, it'll automatically take the first one. Okay, and then since we have to do this in multiple parts, we'll have to make them a multiple line one. So we'll have to put in these curly brackets. Okay, so we're going to go through the number of tracks. We're going to go through 0 through 7 if we have 8 tracks. But then within that, we have to go through each and then fill them out with a 0, each 1,000. Okay, so within that, and now remember, we've done this before, our second for loop will be with a different variable name. Since we already use I and it's applicable within here, we're going to have to do for loop and usually use j. So for int j equals 0, and j is less than, and then so this will be oh, so you know what, instead of the sample array's length, it'd be just much more clear if we say number tracks, and then if here we put buff size. So this is for every one of those thousands, then j++. And actually we can just put that one on one line, so we don't need that curly bracket. Okay, because that's just going to be one thing. For each of those, we're going to fill it with 0. So we'll say sample arrays, okay, I, which is the track number, and then j, which is the sample number, 0 through 999, equals 0. So this is just filling all our sample arrays with a 0. So we're going to have 8 sample arrays, each 1,000 long, all filled with zeros. Okay, so it'll be that, just that straight line. Yeah, okay. A little bit confusing, but it's the same process. It's just like one more level down, right? Since it's a 2-dimensional array. And since for every track we need an array of samples. So we have just a collection of arrays. Okay. Now let's go to the next part where we have to do with waveform. We have an update waveform and we have a draw waveform. Okay. So what we're going to have to do is we're going to, and this is, we'll just review. This is for one track, and we have our, if the rect, for that one track, if the rectog is equal to 1, then we're going to do it once every 12 frames, because that's a lot of, that's 1,000 bits of information sending 60 times a second. It's unnecessary to update it that quickly because our eye really doesn't update that quickly anyways. And the waveform is just sort of a rough display. So as far as we're concerned, we don't need that quick an update. So every 12 frames, it updates. And then remember, it sends this message waveform, which tells SuperCollider to send us all that, the new waveform information from the buffer, this resampled buffer. Okay. Except we've updated that to also include the tracks. We have to do that. So the few things again we have to do is we have to make sure this isn't that sort of kind of crazy for loop, and we have to update each track, and we have to see if the track is being recorded, and then it's only updating when it's recording. Okay, so we have to put it in this sort of dual array. So just bear with me. This is going to get wordy, but not necessarily overly complex. If you can just sort of, put your thinking cap on a little bit and update increase the concentration just a tiny bit here. Okay. So first of all, we're going to for loop through the number of tracks. So that's because we have a 2-dimensional array. The number of track side of that array, we'll say. So for int I equals 0. I is less than number tracks I++. And then again, make sure our curly things are lined up. This ends this for, and those are the two things we want to include. Okay. So we're going to go through each of the sample arrays, okay, or the tracks. All right. If the rectogs, right? So it's that array of rectogs, I, right, is equal to 1, right? It's for every track it's going to see, is So we can have more than one track recording at the same time, right? So is track 0 record 1? Is it recording? Yes, no. Is it yes, no, 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 yes, no, okay. And then it's still going to update just once every 12 frames, so we don't need to alter that, okay. And, right. So the update waveform is easy because it's just one per track, so we don't need the J in there yet. We don't need the second D, the second dimension of that array in ACT, because it's just per track. If we're recording, then we're going to update that for that track. And in order to update that for that track now, we have to add, remember that bit of data, which is the track number, which now we updated a couple of tutorials ago. It's expecting the track number as message 1. Yeah. And then it's going to update our function. It's going to call this function waveform with the buffer and the track number. So it's looking for the buffer and the track number, and then it's going to resample it and then send it back to us as this resampled array. Okay. Oh, and then we have to adjust that now. So we have to remember to do that. Not only is it going to send this resampled array back. Oh, no, we already did that. We inserted the track number in there. And track end? Yeah. Okay. So we resample that in there. I feel like I made a mistake here somewhere. No, that was just this track. Okay. Yeah. All right. Yeah. Already that's being inserted as the first one, but we do have to extract that in our return. So we have to remember to do that. Yeah, but don't worry about that right now. We'll get to it. But the point is we have to add this little bit of information. So OSC message is called wfmsg.add. And what do we have to add? It's the track number. It's the I. Okay, so the I. Yep. And then it's send this wfmsg. So now it's going to look like waveform plus the track number. Okay. And like I said, it could be more than one track number recording. So for all the ones, that's why you do the for loop. For every track that is equal to 1, we'll send this waveform message, and it'll update once every 12 frames. Now, when we draw the waveform, though, it's sending this information back, okay? And we'll get to that again. But we have to update the samp arrays, right? So this line this is where we have to update the samp arrays, okay? So for samp array.length, it's running this for loop, and then it's going to update that line. It's going to update every point, actually, every pixel in that track, okay? But we have to make sure it's updating it's using the right samp array there, okay? So first thing, just to make this slightly neater, and I can't see the end of my line here. So this is x1, y1, right? All that's y1. And then this is x2, y2. So I'll just hit that like that, okay? And x2, y2, right? x2 and y2. x2 is I and y2 is all that stuff. Now, one of the problems already I see is that this for loop is within my greater for loop, which is I, right? So I used this big for loop for both of these, yeah? But then I'm using I again down here, which I can't do. So instead of changing all these I's, I can simply change this one to J. I guess there's enough changing for both, but let's just do J first, and then we'll do I within, so we don't have to change it. But of course, we have to update that to J, and we have to add track J there. Okay, so we'll just these are the bits we added just now, and we'll just make them J instead, so we don't have to redo the code down here. All right. Now this is drawing. Remember, it's samp arrays, the two-dimensional array. All right. So it's actually looking within the samp array. So for int I equals 1, and remember we went through this because the first one is the OSC name, and the second one is now the track number, right? So we're going to actually do from int 2. Int I equals 2, and I hope this is correct. Right, okay, so let's see if we can wrap our brains around that. It's a lot of information to sort of keep track of. But when we send this resamp array from processing, now this is an array of the amplitude or the value of every single sample, but resample in that buffer, but resample to 1,000 pixels. So for 1 for every pixel, okay. We added 2 bits of information because of the way, and there probably is a better way to do this, to be honest. But I tried a couple different ways and it didn't quite work just because of the way processing is a bit persnickety, the way it handles these large bits of data sent over to it. So we insert within that, we're just sending one array, but we insert 2 bits of information. So the very first piece of information is the OSC name or the address, because otherwise it won't be received as sbuff. That has to be the first tag. And the second bit of information will be the actually track number. Okay, so we have to extract that as well. All right. So, which we'll pass actually in later. So we won't worry about that as well. But just to note that the sample array will actually be, sorry, let me just see what happens here. Just bear with me a second. Sample array I minus 1 equals message.get I. Ah, right. Okay, so sample array will still be just the size, okay? We'll change it all down here, so we don't have to change it here. And I don't know why I did 1. Oh, because we're doing minus. That's right. Never mind. I'm sorry. Okay, so scratch all that stuff. I'm just confusing things more. I do that sometimes. Right, because I wasn't really following myself. So this is 1 only because we're drawing a line from 1 pixel to the next pixel, right? And so we start with 1 because we can't go back. So if it's 0, if I is 0, we can't go to I negative 1 because sample array negative 1 doesn't exist, right? So we're going to go to the next one and we're going to draw minus 1, which is 0. So if it's the first one, if I is 1, then we're going to draw from 0 to 1. And then the next one we're from, the next one will be 2. It increments to 2, so it'll be go 2 minus 1 from 1 to 2. And from 2 to 3, etc. You probably knew that already and caught my mistake. Okay, so we don't need to change this at all. We change that the way it receives down there, and we'll get to that later. Okay, so in fact, what we're going to do is a better way to express this is I is less than, what is it? Sorry. Buff size, yeah. Okay, which will be that 1000 number. And we're going to, for int I buff size, we're going to make it's going to be sample arrays, right? And so, just this is where it gets a little bit, sort of a mind melt a bit. These 2D arrays can be a bit like that. But you get used to them anyways. So we are already looking through, we're already looking through the number of tracks. For every track, it's this J, right? So track 0, or the first track, 0th track, will be J equals 0. Second track, or the 1th track, will be J1, etc., right? So we have to look at sample arrays J, and that's track number, and then I1 or I minus 1, okay, right? So that's all. We're just adding a J in there. So it's going to look at the sample arrays for that track number, and it's going to take that particular sample, right? Okay, so we'll update this as well. It's the same thing, J, I, okay? And sample arrays, right? So that's fine. It's going to draw a line from there to the height. So the X is fine because it's going to draw pixel by pixel, one line for every pixel to the next pixel, from 0 pixel x0 to x1, from x1 to x2, etc. But before, since we were dealing with just one track, we had a height divided by 2. But this time, we want to draw from the middle of the line, which is the track height divided by 2, right? TRHT, track height divided by 2, okay? And then remember, we're going to add whatever is coming from our sample. So yeah, look, if this is getting super confusing, I'm sure, but look at that past, maybe back to back, the past tutorial that explains all this, and I'll try to explain it again. But basically, we want from the middle of the track, right? We want to draw a waveform up and down. So if it was sine wave, 1 would be up, and then it would be down. -1 would be down, right? Okay. So then the sample arrays J, will be that sample, will be just a number, which is that amplitude value, whether it's 1 or -1. And then we want to times it by half of the height of the track, right? So it's the track height divided by 2. And this -2, the negative is added just because in processing we count down for positive y goes down, right? So 0y is up here, and if our thing is whatever it is, 800 high or whatever high, that's going to be down here. So it's 800 high, 800 will be down here, right? So that's just inverting that, so that we subtract positive and we add negative, right? So then if that's the middle of our track right there, positive will go up and negative will go down. So that's why that negative. And track height divided by 2, right? Okay. And then so the same thing here, we have to update that. And then update that as well, track height. Okay. So I don't think I missed anything. Hopefully that is there. So that's probably the most sort of just mind-melting part of this code. But totally understandable, I think. Just have to take a little bit of time to cram it into your head. All right. Let's save that. And I think that'll do it. Oh, we do have to update down there the way it takes it in. Okay. So the beat grid is okay. The beat marks are okay. Pause height okay. All that's okay. Now it's this, remember OSC event, we had to do a special way to bring in that big bit of data. And OSC event takes in all the OSC events. So every time an OSC message is sent to it, it's sent to this method right here. And it's going to check if the address pattern is SBuff, and automatically checks the first part of that array. So that's why this has to be in the 0 slot, this SBuff, and that's what we did in SuperCollider. We stuck that symbol SBuff/SBuff into the 0 slot of that big array that we sent, and then we sent it all as an array. And then for int I equals I less than buff size I plus plus, if I is greater than 0, then sample array, we're going to fill that sample array, okay? But now we have to couch this whole thing. So this is for one track, this for loop, okay? And let's just put some spaces around, some hard turn. That's the end of the for loop. Let's just isolate that. So this whole for loop here is for one track, right? It's going to fill from the message we get from SuperCollider, it's going to fill that sample array, right? Of course, we have to update the name and everything like that, okay? But instead, now we have to check for the we have to check for the the track number, okay, which will be our the second slot. That's in the first slot, or slot 0. In slot 1 will be the track number, okay. So we're gonna just create and let me just confirm this. I'm gonna look at my old code. I'm pretty sure. I'm just kind of doing this from memory. Open recent, and do we still have that? What is 4? Pretty sure I'm doing it this way. Let me check and see if I did it a different way. Okay. Oh, and then I had that fancy which track. Oh, well, that's okay. Integer track. Yeah, track number. Okay, I did do that. Okay, so we're going to just create a temporary variable here to hold our track number. So we're going to say int. Why is it 0? Get 0.int value? Is it really? Well, it seemed to have worked. I guess it just eliminates that somehow. So it comes in and it just takes that off. So SBuff, yeah. So it comes in, it takes that off, and it doesn't include that with the array that gets passed through. So I'll say integer trn equals, and just get the message.get 0. Okay, so we're going to do message, which is this OSC message that's coming in, message msg.get, and then which part of that message, since it's an array, get item number 0, which is the very first one. So it slices that one off. So then the first one now will be our track number. Okay, and then .int value. It's a bit of a convoluted syntax, but that's fine. .int. Okay, is that a capital V? Int value capital V, and it has it's a method, so it's got to be have the parentheses. Okay, so this will get the 0th of the very first part of the message that's coming in, and it'll make sure it's an integer, right? And then now this trn will equal that, which will be our track number. Okay, and so we're going to go for the buff size. We're going to go through, and if I is greater than 0, which means it starts on the first one, because this is now, the int is the first one, I believe. Yeah, this is where I'm a bit confused, a bit in the dark here, but that's okay. Let's just roll with it. I'm pretty sure we just keep that at 0. Maybe not 2, maybe it's still 0. We'll see. And then we're going to get sample arrays, right? And which sample arrays? Well, the track number. So we're going to hit that. It's going to be trn, right? So the first of our 2D array, the first slot is which track number it is, and then the sample. So it'll be I minus 1. So it'll get, now why do I do it's greater than 0 and then I minus 1? Don't know. Anyways, oh, right, because we're starting on number 1, right? And then we're sticking it in starting on 0. So that's all. We have to adjust the index of the sample arrays, right? Okay, so if I is greater than 0 starts us on I1, okay, because we have to skip this track number. And I thought we had to skip this as well, but we'll see. And then we're still gonna stick that bit of data in as sample arrays starting at sample array 0, so I minus 1. So if I is 1, then it'll be I 0. Okay, and that's because we add here the sample size here when we sent it. We add 2, insert 0, because it's sample size, resample array is sample size plus 2, all right? And so we send, it's actually 1002 because we add the track number and the sbuff. Now, I don't know how we just got rid of the sbuff, so I'm just going to roll with it. I think somehow this gets cut off, but if not, we'll just have to update. That'll have to be 1, and this will have to be greater than 1. Okay, but in any case, sample arrays, track number 0, so starting at sample arrays for that track number, slot number 0, is going to equal the message, which are all the samples, dot get I, which is going to be, starting at 1, dot float value, okay, all the way through the buff size, which will be 1000. Okay, so hopefully that works. Keep our fingers crossed. I think it will. Okay, and I think that's everything for our buffer. So let's run this and see if it runs first. So no mistakes there. Okay, and then we'll run all our SuperCollider code, recompile, boot the server, run all that code, and then start our synths. Okay, and that's rolling. And let's record here and see if it's working. It's not working. Oh, but it puts it on 1, so it didn't update our track number, because I think that little blip I said you. So it's drawing the waveform there, but it's actually on this track. Record here. See. So it's just the way it's drawing. Okay. So let's see where we made our mistake. Let me kill that. Do we make our mistake where it's drawing? I have a feeling no. Oh no, that's the other one. I have a feeling no, it's not the mistake where we're drawing. So let's look at the draw first. It says, and good thing we labeled it, draw waveform. Okay, it's drawing sample arrays J, I, yeah, I think that should be okay. Line, right, track height divided by 2. Okay, so it's just updating that one. So it must be the thing that comes in. So I'm wondering if this is not 1 instead. And I'm wondering if this is not greater than 1, like that. Okay, let's try that. If that's wrong, it'll do this buffer overrun, Java buffer overrun kind of error. That means we are trying to send it more information than we have room for in our buff size. So hopefully that's okay. Let's run that. And okay, oh yeah, I stopped all that. So once again, just go through all that. I'm sure I don't have to recompile every time, but Why not? To make sure we're on the up and up. That's going. Hello, hello, hello. Yeah, it's not drawing at all, huh? Okay. Well, let me just pause out of here and solve this so you don't have to painfully watch me go through it, and then I'll just update you. Be right back. In fact, you won't even notice I'm gone. Hello, hello, hello. So, in fact, it was still 0. It does just cut that out, I believe. I haven't tried it yet, so you'll have to maybe watch me fumble out. But it is this 0 still, so the 0th information is going to be the track number still, because somehow it cuts that out when it receives it. But all I did was still greater than 0, except I'm sticking it in 0. Okay, so in fact this 1, it starts on 1, but the 1th of this message, so if we presume it's 1002, 1 gets cut off here, so it's 1001 long now, and the first message is the track number. Okay, if we start on number 1, then it'll be 1000 long, right? And then if we put number 1 into 0, into 1, I see, but then we're just missing out the first sample. Oh, interesting. So I guess I didn't foresee that. So maybe I was right. Maybe it's better to do it this way. So if we do I is greater than 1 and put this in I minus 1. Oh no, put it in I minus 2. That's right. Okay. So if this is 2, it starts on I2, then it'll put it into slot 0. So 2 will go into 0, 3 will go into 1, etc. Okay. Fingers crossed. Let's see. Get I, right, I. That's because we're incrementing that up too. So fingers crossed. Hopefully that works. Again, I think I have to reset all this. And let's see. Hello, 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 hello. Ah, no, it still is recording on number 1. All right, well, here, pause again. I'll be back. As painful as it might be, it might actually be useful for you to go through this with me as a troubleshooting exercise. Okay, so, if you don't feel like doing this, just skip over this part and get to the answer. You can just skip ahead. The magic of YouTube or the internet. Okay, now, so I'm confused personally about which one is my track number. I know it's clear in SuperCollider that I'm sending a big array, this resamp array, and I know the first one is this sbuff, and then the next one will be this track integer. So 0, resamp array 0 will be sbuff, and resamp array 1 will be the track number. Okay. So let me just print those out and see if I'm right. Okay, so turn to the int value, and let's just print track number. Okay, so we'll say print trn. Okay, so whichever I hit should print out there. All right. Right. Okay. So we will again run all this stuff. Boot, send, and run that. And so whichever one I click should print the 3. So that's right. 0, 1, 2, 3. That's correct. And then 6. Good. So that works. Okay, and I'll just mute it so we don't have to deal with my recorded voice. And then, so that's okay. So that seems to be okay. So track number is a message 0, MSG 0. So if I start on I equals 0, should print the 3. So that's right, 0, 1, 2, 3. That's correct. And 6. Right. So we have to do message 1. That's right. So if it's greater than 0. That's correct. So we're starting on message 1. Okay, so it does cut that off. And then I minus 1. Message get I, float value.
Should print the 3.
Track
That's
number.
Right, 0, 1, 2, 3.
Sample arrays that. So maybe it's just the draw is
6.
wrong, because this seems to be all correct. If I is greater than 0, which is starting on number 1, because message 0 is that.
Should print the 3. So
I buff size, okay. So there is some kind of confusion here, because I have a for loop and then I have a message. They're two different things. And I'm only for looping through the buff size, right? So in fact, I do need every I.
So that's right, 0, 1, 2, 3.
Except I'm just going to get message. I'm going to update the message, right? So a better logic would be to go through the buffer size. And for some reason, I got rid of this and I thought I did it right, and then I didn't do it right. So we'll just try it again. We'll get rid of this. And I do want to just do buffer size. I do want to do 1,000 of them. And I'm going to start on track arrays, track number, right?
Should print the 3. So that's right, 0,
That's clear, because the tracker number is being passed clearly through the message 0. That's the message I get. It's this big array. So that should be copacetic. And I want int sample arrays I 0 to be equal,
right, 0, 1,
but I want to do message I plus 1. So hopefully that works, right? Because message now, if message 0 is this integer value, is the track number, then message 1 should be the very first sample that I want to get, right?
3. So that's right.
And message should be 1001. So it should fit into buff size 1000, right? So this should work. I should get the second one. So if it's 0, I should get the second one when I 0, but it's going to put in sample array 0.
So that's right, 0, 1, 2, 3.
So hopefully I won't get those overflow, that Java overflow, array overflow things. Now, I have a feeling then maybe my mistake was how I draw it. Maybe you caught it when I was earlier. So when I want to draw the waveform,
so that's right, 0, 1,
I want to draw it to the sample arrays track height. Right, track height times I, of course. So it's not just track height divided by 2. It's track height divided by 2
should print the 3.
plus track height, right? Well, isn't that what I did here? So this is adding the sample. All this business is adding how much sample is offset from here. Right. So I'm just drawing it wrong.
Right, 0, 1,
So I'm going to do it track height divided by 2 times I. Yeah? Does that make sense? Oh, plus I times track height. Okay, so this I times track height will give me I times TRHT will give me which track I'm on, right? That's the Y value. And then I'm going to add it to all the rest. Okay? Okay, so let's walk this stuff through. It's so confusing. So I times track height will give me which track I am on. So if I'm on track 0, then that starts on 1. Oh, J, I'm sorry. So these are J's. So the tracks are J's. So this is where I's are the samples and the tracks are the J's. So it'll be J, right? Okay. Yeah. Now I'm understanding myself. Remember we did this for loop for J will be the track number. Okay. So if we do the J times the track height. So if it's J is 0, first track, that'll be 0 plus track height 2 to get us halfway down the track, right? To the middle of the track. So we can go up and down. And then this will be the sample. That's wherever. It's either negative below the middle or above the middle, right? And then x2 will be I because we're going to draw from the first pixel to the next pixel. And then this will have to be, this Y will have to be the same. So we're not only adding, we're doing the exact same thing. We're going to do J plus times track height plus half of the track height, which will get us to the center of the track, plus these sample arrays, which will be JI. So that track number plus the proper sample, right? This is I minus 1 because it's the one before. And that should still be okay, times track height minus 2, right? Because this whole thing is just how much we add to this bit. Okay, so it's just where I was drawing, and everything else should be fine. So hopefully now I just simply don't get those overflow things. And I just want to get rid of that print. I still printing? I feel like I'm still printing. No, I got rid of it. Okay.
Print the 3. So
All right.
right,
Thanks
0,
for
1,
hanging in there with me
correct.
on that. And hopefully it works.
6.
Okay. And yes. Okay. So it's drawing the thing. Excellent. Stop that. And I'm going to unmute it so we don't, we can still, it's drawing my waveform. And yes. Okay. So I'll stop that here and we'll record on this track. Hello, 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 hello. I'll record on track 1. 1, 2, 3, 4. So we can start recording.
Hello, hello.
Okay.
1, 3, 4.
So hopefully it's not the case. So that works. Brilliant. So hopefully it's not the case that my SuperCloud code is messed up. That's why it's so distorted. I don't know. I actually fiddled with it and seemed to get it to work. I just might have to restart things. Maybe have too many things running. I think that could be the problem. Okay. Anyways, that works. So there you go. A bit confusing, a bit kind of, this may be the most sort of mind-numbing or mind sort of stretching part of this whole tutorial. Just trying to understand these 2D arrays. That can be a bit of a, mind melt. But essentially we got it working. So we're drawing waveforms on every track individually. We have beat markers on every track. We can pause and record and play on every track individually. Okay. So the next tutorial now, we're going to again mess around with our code, unfortunately. And what we're going to have to do is we're going to try to get so we can grab parts of our loops. But of course, that's going to mean us moving a bit of the way we structured our record and play buttons. And I just did that initially just so we can have something easy to put in. We're not get too hung up with a GUI. Usually the graphic user interface or the GUI takes just a lot of haranguing, and sometimes you spend most of your code just trying to adjust the GUI. So we're just going to move some things over and we're going to get it so we can do the loop functionality. Okay, so hopefully that was a long and painful bit, that tutorial, but hopefully you got your way through it. Again, just repeat it as many times as you want to try to really get the concepts there and see if you can get to a point where that makes sense to you and you can do it on your own. Okay, well, good luck with that.